This is K. Narsaiah, SA Social Studies, GHS Narendra Nagar, Warangal Urban. In the previous sessions, we learnt about the first two chapters of 9th class Social Studies. Today we shall learn about the third chapter, Hydrosphere. Hi viewers, we shall learn about hydrosphere in this session. Since this is a digital lesson, there are slides being shown. While watching, you may pause and note down important points. Since the time immemorial, it has been raining. We find water in oceans and seas. Have you ever thought about why the water in the seas and oceans never dries up? Less than 1% of water that reaches the earth is useful to human beings. Is such less quantity of water sufficient for human needs? To know such things, let us read about hydrological cycle. So here, to know such things, let us read about hydrological cycle. We know that water is a recyclable, renewable resource. Water goes through a cycle from oceans to land and from land to oceans. Hydrological cycle refers to the continuous exchange of water between the oceans, atmosphere, land surface, subsurface and all the living organisms. Now you look at a formula shown on the slide. The formula is rainfall is equal to runoff plus evapotranspiration. In simple words, RF is equal to rainfall and RO is equal to runoff and ET means evapotranspiration. So in the hydrological cycle there are 6 stages. The first one is evaporation. So evaporation is the process by which water changes from liquid to gas. Transportation. So the transportation is nothing but the movement of water through the atmosphere, specifically from over the oceans to over land in the form of clouds. It is transportation. So are you listening to me carefully, children? Next, the third stage in the hydrological cycle is condensation. The transported water vapor eventually condenses and it forms tiny droplets and clouds. So this process is known as condensation. And precipitation is the fourth one in the hydrological cycle. So it is a primary mechanism for transporting water from the atmosphere to the surface of the earth. So there are various forms of precipitation: rainfall, hailstones, snowfall, sleet, etc. The runoff is the fifth stage in the hydrological cycle. Most of the water which returns to land flows down the edge as a runoff. So have you ever observed the rainfall? When the rainfall occurs on the mountain regions, it flows down to the bottom of the mountains. That is called runoff. Next and the last stage in the hydrological cycle is groundwater. So when the rainfall occurs, it flows on the surface of the earth as well as on some of the water penetrates into the land and charges the groundwater. So you may look at this picture. Viewers, you observe this picture. So the water in the oceans move upward in the form of water vapor. After reaching certain height, the water vapor condenses. The water vapor condenses and forms as tiny water droplets. Then they become clouds. When the winds blow, they move towards lands. Then they come down as rainfall. Rainfall is one of the forms of precipitation. As we learned earlier, precipitation includes snowfall, sleet, hailstones in addition to rainfall. So if you have, I think you have observed the cycle and you have understood the water cycle in a better way. Now you look at the another picture. So that is, it explains clearly the water cycle or hydrological cycle. Shows how this picture also shows how water moves from oceans to land and land to oceans. So plants use groundwater through roots and grow. So you may look at this. So this arrow shows the water which is taken by the plants. The plants release some water into the atmosphere through transpiration. So you may observe here. And due to the heat of the sun, water in the oceans and sea evaporates. You look at here. Evaporation starts in the oceans and seas because of the heat of the sun. And when this water vapor reaches certain height, it condenses. Then clouds are formed. So with the particulates in the atmosphere, when the winds transport these clouds to lands, precipitation occurs. In this way, water reaches surface to the earth again. Now we discuss water sources and oceans. Of the total amount of water on the earth, there is approximately 97% of saline ocean water. Only about 3%, that is 2.7831% exactly, is fresh water. If we take total fresh water as 100%, there is only 69.56% of water is there in the form of ice and snow cover. So the snow cover is found in the Antarctic, Arctic and in the mountain regions. Fresh groundwater is 30% approximately. So only 0.34% of water, fresh water, that is in the lakes, reservoirs and rivers system on the earth. So we use two different words to express water bodies. What are they? Do you know? Sea and ocean. So sometimes we use them interchangeably, but there is a difference. The large water bodies are called oceans. Example: Pacific, Atlantic, Indian, Antarctic and Arctic oceans. A body of saline water, partly or fully enclosed by land, is called a sea. Example: Arabian Sea, Mediterranean Sea, like that. The major oceanic divisions are defined in part by the continents, various archipelagos and other criteria. Now let us discuss the relief of the oceans. Like on the earth, there are submarine ridges plateaus, canyons and terraces found within oceans. You look at the chart being shown. So it explains about the divisions of ocean floor. Children, have you observed how many divisions of the ocean floor are there? Yes, there are 4 divisions of ocean floor. The first one is continental shelf. And the second one is continental slope. Third one is a deep sea plain, which is also known as abyssal plain. And the last one is oceanic deeps. So in other words, we can call it trenches. From the surface of the ocean, water to a depth of 200 meters, there is a continental shelf. It is the border between the land and sea. It occupies 7.6% of the ocean area. And the continental slope is spread from 200 meters to 300 meters depth. It comprises of 15% of the ocean area. Deep sea plain covers about 76.2% of the ocean basin. The depths vary between 3,000 to 6,000 meters. Oceanic deeps have a depth of up to 6,000 meters. So oceanic deeps are trenches. So these are the large narrow trenches. So they occupy 1.2% of the ocean area. Formal oceanographic investigation began only with the British expedition of Challenger. Of the 4 divisions of the ocean floor, continental shelf is most important part because we find fish wealth, crude oil, natural gas and building seaport. The deepest trenches are found more close to the continents, and as many as 57 deeps have been explored so far. To understand the division of ocean floor, now you look at this picture. So here we find the green color shows the continent, and here we find continental shelf and continental slope. Here you can find submarine canyon, and this large part is abyssal plain. So do you find a raised part of the abyssal plain? This is known as mid-ocean ridge. And here you find a trench, deep part on the ocean floor. So children, you have understood well, I think. Now we go for another topic. So far we have learnt about the relief of the oceans. Now we shall know about the salinity of the ocean. When the rainwater speedily runs off hilly rocks, some rocks particles are dissolved in the water. The rocks contain the compound sodium chloride, NaCl. So this is compound sodium chloride is carried into the sea. So you may observe this slide. Over millions of years rain, rivers and streams have washed over the rocks. The rocks contain the compound sodium chloride. When water evaporates from the surface of the ocean, the salt is left behind. The oceans have developed a noticeably salty water over millions of years. So here we find a word that is salinity. Do you know the meaning of the word salinity? If you do not know, we shall learn it now. Salinity is the term which is used to define the total content of dissolved salts in seawater. How do we calculate this? It is calculated as the amount of salt in grams dissolved in 1000 grams of seawater. It is expressed as parts per thousand. Have you observed this symbol? Don't you treat this as percentage. It is parts per thousand. So you find two zeros after the slash. It shows that it is not percentage, it is parts per thousand. Simply we call it PPT. The average salinity of the oceans is 35 parts per thousand or 35 ppt. When you take ocean water randomly, it has a salinity of 35 parts per thousand. For example, if you take 1000 grams of seawater, there is 35 parts per thousand salt in that water. Next, we go for sodium chloride. So sodium chloride alone constitutes 77.8%. So it means that most of the saline water is dominated by sodium chloride. Rainwater contains 2 parts per thousand of sodium chloride. If you take 1000 grams of river water, you find 2 parts per thousand sodium chloride in that. So in the same way, there are isobaths. In the earlier classes, you might have heard about this word, isobaths. Isobaths are nothing but lines joining points on the seabed at and equal vertical distance with the surface, sometimes referred to as depth contours. In the 7th class, you studied about contour lines. In the same way, isobaths are depth lines drawn on the surface of the ocean floor. Next, isohaline is a line which joins the points in the oceans having the same degree of salinity. It means that there are places in the ocean water which have same degree of salinity. If we draw a line connecting these places, it is called isohaline. Then we go for the next picture. If you look at the picture, you can understand the salinity of seawater. So where do we find fresh water? Fresh water is found in ponds, lakes, rivers, streams and aquifers. So what is the salinity of fresh water here? So 0 to 5 ppt. And brackish water, estuaries, mangroves, swamps. So in this we find brackish water, saline water. So saline water is found in the oceans and seas, sea water, salt lakes like that. There we find 30 to 50 ppt in such a water. And there is another one, that is briny water. Briny is a word which shows the, it is called containing the salt in the water. So you find here there are some seas mentioned: Red Sea 40 ppt, Mediterranean Sea 38 ppt, average sea water 34.7 ppt, and Black Sea 18 ppt, Baltic, and like that. You may see this. Now we go for the factors affecting salinity. So we know that the ocean water is salty. How does this salinity happens to the seawater? Where evaporation is more, there is more salinity, and vice versa. It means that evaporation and salinity have a positive relation. If one increases and the other increases. Where precipitation is more, there is lesser salinity. So there are some factors which affect salinity on the surface layers of the oceans. First one is evaporation and precipitation. The second one is in coastal regions where the fresh water flow from rivers. So when the rivers reach seas, they decrease the salinity of the seawater because of the fresh water flow. The polar regions also we find less salinity of water because there are ice and freezing points. Winds also cause the salinity by transferring water to other areas and the ocean currents. Next we go for ocean temperature. When compared to land, the temperature in the oceans does not show much variation. The ocean temperature is influenced by latitudes, winds, ocean currents, unequal distribution of land, and the change of seasons. You know that at the equator there is high temperature, and at the poles we find minus degrees temperature. Normally, the temperature in the oceans varies from minus 2 degrees centigrades to 29 degrees centigrades. When we look at the vertical distribution of temperature, we can find this. As one goes deep inside the oceans, the temperature decreases. Ocean currents. The ocean current is the general movement of a mass of water in a fairly defined direction over a great distance. The sea water is not still, it moves. That is called a current. It moves over a great distance. When we consider temperature, there are two types of ocean currents. In other words, based on temperature, ocean currents may be classified as cold currents and warm currents. Warm currents flow towards the poles, cold currents flow towards the equator. The current that flows speedily is called a stream. So, and the water that flows slowly is called a drift. So, this division is done on their speed. So, in other words, we can say that based on their speed, ocean currents are divided into two. They are stream and drift. So what are the causes for the ocean currents? So there are some causes for the ocean currents. Now you look at the slide. Centrifugal force, which is greater at the equator, makes the equatorial water move towards the poles. Second one is effect of winds. Due to the frictional gliding of winds, it means the water on the surface of the water, the wind blows, it moves. The water is dragged along the wind direction. Third one is precipitation. The equatorial areas receive the greatest rainfall. As a result, water moves north and south from the equator. So we know that there is much precipitation on either side of the equator. When there is heavy rainfall, the water moves in either direction of the equator. That means it moves to north and south. Fourth one is solar energy. Heating by solar energy causes the water to expand. Hence the water is about 8 centimeters higher in the level near the equator than in the middle latitudes. This makes water move. And there are some other reasons for the ocean currents. That is salinity, density differences, melting of ice also affect the ocean currents. Now the uses of ocean. So oceans are also used as a resource. Human beings have depended on oceans for their food and livelihood from the ancient times. We use the sand, gravel, etc. for our industries or housing. So we find the number of minerals in the seawater. Example, chlorine, fluorine, iodine and oils, etc. Nowadays we use waves for generating power. The power is known as tidal energy. In some places of the seas we find gems and pearls. When we look at the history of human beings, we find civilizations occurred on the shores of oceans. So oceans created civilizations. So oceans and seas are also used for international trade. So with this we have learnt about hydrosphere. Thank you, viewers. Explanation so far. I want to conclude the chapter now. I hope that you have understood well. So if you do not understand, you may watch it again. Then you will know about it clearly. Thank you for watching.